Hi, I am Nat, and today we will now do a review of Randall Munroe's book, How To. I even have a physical copy of this book, which shows just how much I love this book. How To is an extremely impractical self-help guide, which is hilarious to scientists and non-scientists alike, myself included. Here are all 28 chapters on this book. It covers very diverse topics like how to power your house, how to mail a package, how to tell when you're a 90s kid, how to dig a hole, how to play the piano, and how to predict the weather. One of the chapters, How to Build a Lava Moat, was the subject of a video by Minute Physics. The link is in the description. Another one, How to Throw Things, was a subject of a calculator by Randall himself, and it even has Pikachu, along with several units like rad units, smoots, and attoparsecs. My personal favorite unit, which is approximately equal to 3.09 centimeters or 1.2 inches if you use a previous system. The link to this is also in the description. Of all 28 chapters on this book, the one which resonated with me the most, pun intended, was chapter 4, How to Play the Piano. In this chapter, Munroe describes the 235-key piano, which apparently covers the whole of meaningful music from infant sound of the sea to dub and back music, ultrasound. This piano gives you just over 19.5 octaves from G sharp 97 to D13. Why not to test your hearing? Let's just hear this 16 Hz tone created with an online tone generator. If you can't hear it, well, very interesting to hear that because most of us humans can actually feel this note. But anyway, the lowest frequency humans can hear is actually 20 Hz. To explain this phenomenon, let's look at Randall's extended versus human hearing. So the lowest note of Randall's extended is around 0.2 Hz, and the highest note of Randall's extended is around 150 kilohertz. Occasionally you might see these values in Hertz, but I wrote them in Hertz just so we can make it simpler. So the lowest frequency humans can hear is 20 Hz, and the lowest note of Randall's extended is just under 100. 100 frequency lower than this one. The highest note of Randall's extended is actually 10 times above the highest frequency humans can hear, just under 10 times, around 7.5 times. But who cares? It's around 3 octaves higher. And so, if you can try to make Randall's extended, well, try. Use piezoelectric transducers for ultrasound and rotary woofers for infrasound. This can be used to cover the whole range of Randall's extended. But there's another way which Mr. Munroe did not mention in his book. It's more of a cheat instead. To use more notes per octave. Well, how many notes per octave can be used to apparently, as he quotes in his book, play Beethoven to the haunting sounds of the music itself? Answer, just intonation. Just intonation is a tuning system which is based off the rational numbers. This is then based off the harmonic series, which creates the rational numbers, which create just intonation. To understand the harmonic series, let's just take the lowest note of Randall's extended, G sharp negative 7. Multiply the frequency on this by 2, 0.4 Hz, G sharp negative 6. Multiply 0.2 Hz by 3, a little off from D sharp negative 5. Let's just stop at 3 here. But obviously, and you might know this, just for curiosity, it becomes G sharp, G sharp, D sharp, G sharp. C is actually B sharp, D sharp, F sharp, G sharp, and then it goes on and on and on until D13. Well, actually it goes on for more than that, but D13 is probably 150 kilohertz. That's where we stop. Irrational logarithmic multiples on an octave, about 1.584 octaves, or log to 3. And if you take successive rational approximations of this, using the continued fraction expansion gives 3 halves, 8 fifths, 11 sevenths, 19 over 12, and 65 over 41, which means you can have pianos of 2, 5, 7, 12, and 41 notes per octave. We can just take away the first 3 options because that's what we're not going to explore. And 12, we already have one. So now let's look at 41. If you want to learn more about alternate musical tunings, look at Xenharmonic Wiki for more information. But be warned, Xenharmonic Wiki will need lots and lots of matrix algebra. Whoops, there's a battery saver warning. I'll have to take this off. Great, much better. Using a 41-tone piano can give us a cheat to add more keys in a narrower range. Assuming our hypothetical 41-tone piano has the range of Bosendorfer Imperial, a 290, 8 octaves. Number of keys needed to make this piano? 41 times 8 plus 1 is 329 keys, possibly twice why you want to include playability issues. Even better, we can make this piano without having to use any fancy technology and still get it greater than 235. Well, isn't that amazing? We can use alternate tuning systems to create pianos of more than 235 keys. Incidentally, 235 is just close to 299, which is now my favorite prime number because it occurs in the formula for pi, known as Machin's formula. Thank you for watching this video. Be sure to like and subscribe.